Okay. Is everybody ready?
I can ask my question.
All right. Vocabulary words. These are words you're going to see throughout the unit. I know I've already told you this. You don't have to write these down because you will see them again. Line. Essential questions quiz on Friday. You better be able to answer these essential questions.
So it's going to be...
How do the wave and particle natures of light compare? What is the quanta of energy and how is it related to an energy change of matter? And how do continuous electromagnetic spectra and line, we're going to call this line emission spectra,
Why'd you change it?
because I don't like that word.
Okay.
I've never called it atomic. Line emission spectra, compare, and contrast. Okay, so these are essential questions that you need to know to be successful on the test and quizzes. So first of all, we left last unit here. Whose model is this that we are seeing? Rutherford.
My boy Ernest.
Rutherford. And so Rutherford said we have this nucleus in the middle and we have electrons moving around it. But it didn't explain how they were arranged. We know that they're there. We just don't know how they're arranged. And we also don't know why, if we have this positive center in there and it's pulling these electrons in, why do they just not fall in? Why are they not pulled all the way into there? Why are they stopping at certain places? Okay? So that's what we're going to take a look at. So, in the 1900s, they saw that different elements created different colors of light when they were heated. And this related to the chemical behavior of that element and the arrangement of the electrons. Okay? So, elements emit light when heated. Elements light when heated. And it is related to the arrangement of the electrons. Like we saw in the crash course video, by the end of this unit, you're going to be able to tell me the address of all the whatever atoms, electrons. Okay? But prior to getting there, we're going to talk about wavelength and light, or wavelength and energy and frequency, which you did yesterday. So, visible light, what we see is called electromagnetic radiation. EM radiation. Sorry, going back. EM radiation. This is just energy. An energy that exhibits wave-like behavior. Okay, so wave-like. So, like the waves of the ocean. Alright? We learned that all light travels at what speed? 3.0 times 10 to the 8th meters per second. I'm not always going to give it to you in meters. I might give it to you in nanometers. So 3.0 times 10 to the 17th nanometers per second. This is a constant. It never changes. Microwaves travel at the speed of light, 3 times 10 to the 8th meters per second. UV travels at 3 times 10 to the 8th meters per second. Visible light, 3 times 10 to the 8th meters per second. All light travels at the same speed. This is a constant, and it's on your reference chart, and on the day of the test or quiz or whatever, I'll put it on the board too. And I'll give it to you in nanometers and in meters. On your homework, it's given to you there too. I'm going to make the some people, I'm not going to be able to work problems today in class, so I'm not going to officially assign the homework tonight, but if you know how to work those problems, then you can go ahead and do it and not have homework tomorrow night. It's either way. But I'll discuss the homework too prior to the bell ringing. Everybody good with this?
Yes.
All right. So you should have seen this a couple years ago in 8th grade. Electromagnetic spectrum includes everything. You have radio waves, microwaves, infrared. Once you get from infrared, you go to visible light. That's white light, and that's spread into what we see, the rainbow. So infrared, then red light that we can see. Then we go all the way to violet light. That's the last one that we can see. And then it goes down to ultraviolet. And then you have X-rays, gamma rays, and all that stuff. So when you're looking at something like this, please take a look and see what the arrows are doing. Right now it says as I go to the left, wavelength is increasing. And as I go to the right, frequency and energy are increasing. So what can we say about wavelength? If I increase my wavelength, so if I increase my wavelength, oh my gosh, I don't know what is wrong, why this keeps doing this. This must have some kind of like embedded something in here. As I increase the wavelength, what happens to the frequency? It decreases. Decreases frequency. What kind of relationship do we call that? When one goes up, the other one goes down? Inverse. Inversely related.
What color did you write that in?
Oh, sorry. Green. Green. Inversely related. All right, what happens to energy as we increase the wavelength? It decreases. So we also decrease our energy. So what we can see is that when frequency goes down, energy goes down. So frequency and energy, how are they related? Not inversely.
I have a question.
Directly.
Directly, yes. They are directly related. Yes.
So basically, frequency and energy are the same thing.
They're not the same thing, no. They do the same thing, but they're not the same thing.
All right.
Okay. So, and Kalia will be my volunteer in the next step. Okay, so here is wavelength. Waves can be characterized with certain things. They have a wavelength, and that's the length from one part of the wave to the next part of to the same part of the next wave. So here at the top, it's called a crest. So from one crest to the next crest is called a wavelength. Okay? Or you could say from one trough to the other trough is a wavelength. Or from here to here is a wavelength. But it has to be the same part. Yes?
They don't have like a name for the middle part.
No. Okay. Wavelength, I need you to know, is denoted by looks like an upside down Y. That is called lambda. That is the Greek, that's the lowercase Greek letter lambda.
Lambda?
Lambda.
That's wavelength.
What are you looking at me for?
Oh, yeah. That's a whole thing. Everybody, all this background noise is there too. Yes. This background noise.
You take one in every class.
Hey everybody from
No.
the future.
Take it in our class.
Huh?
Take it in our class.
I usually try to take it in third period or second period.
Why are you taking it now?
I don't know. Okay. Any questions about lambda? Wavelength. Yes. Oh, wavelength is measured in meters or nanometers. Okay. Next. Oh, do I... Okay. So what is this?
A prism.
A prism. What goes into the prism?
Light.
What kind of light? White light. And white light does what when it comes out the prism? It refracts into the rainbow, the visible light, what we can see. So this is what we can see. On the other side of red is infrared, which we can't see. Now on the other side of violet is ultraviolet, again, which we can't see. Ultraviolet's what gives you your sunburn and skin cancer. Yes. Frequency. Frequency is denoted with a V. Oh, sorry, here. V. Okay, this is the Greek letter nu. Greek letter nu. On your reference chart, you'll see it as F. You can use F if you want. I use nu just because I can say, hey, what's new?
Get out of here.
So frequency, at a certain point, over so many seconds, that's how many waves pass through. Okay? So, wavelength and frequency are inversely related. So as one goes up, the other one goes down.
Oh my goodness.
Okay, so, Kalia, get up here.
What do you want?
Kalia is going to show me a wave using her body.
No, I'm too big for that.
And what we're going to do is this.
We're not
Kalia.
doing, no, we're not doing the wave.
Yep.
The devil's a lie.
No,
We're not doing
no,
the
it's
wave.
not that. Come on.
I don't want to do the wave.
We're not going to lay on the ground. Come on. All right, you stay right there. All right, so let's make a wave. A wave is going to be from one ankle to our next ankle. But we're going to go down like this.
I can't bend.
Let's go.
What am I doing?
You're just doing this.
Just touch your ankle.
Touch your ankle. Come on. This
I
is gym
can't
class.
touch my ankles. I'm too big. Okay.
Touch your ankles, Leah.
So you really want me to lean all the way over?
Yes.
3, 2.
You got to come back up and then go back down.
I'm out of breath from that.
And then go back
Can I
down.
go now?
Okay, so let's try to...
You can touch your ankle.
I did. Let's
No,
try...
that
Okay.
one. There you go.
Let's try to increase our
other
frequency.
one.
Let's increase our frequency.
I can't.
That means we're going to go... We want more waves passing per second.
I'm not gonna do this with you. They get the point.
No, they don't. They don't get the point.
Do y'all get the point?
No.
Why would
How
I
are we
say
gonna get
that?
the point if you don't demonstrate? 3, 2,
Come on.
1, go.
God.
1.
Increase your frequency. Let's go. All right. All right, Kalia. Now, let's do short waves. Short waves from here to here. All right. 1, 2. Let's increase our frequency. What's happening to our energy as we increase our frequency?
Losing energy.
I'm gaining energy,
How are
right?
we gaining from moving our bodies? That's less.
No.
Energy. How fast are you going? As opposed to this.
Oh.
Do you see the relationship? Get excited like I am.
I can't.
You will no longer be volunteered for this job. Yes, Jalen.
Really?
Oh, hey, can you come up here, please? Oh, well, Jalen, you can come up here. You get it? You get it? You're good? All right. Awesome. Okay. So what happened to our energy as we increased our wavelength? Our energy went down, right? Because it took...
You said we gained energy.
Not when we increased our wavelength.
Okay, wait.
When we had long wavelengths,
Oh, yeah.
our energy, we're slower, right?
What's the wavelength go up, energy go down? What's the Y again?
Lambda, wavelength. Okay? All right.
That's why I'm tired of getting these kids roasting me hard.
All right, this is the same frequency.
No, they're not.
Or the same time. Same amount of time.
Okay.
Who is more frequent?
2.
2. Okay, so this has the highest frequency. Who has the highest wavelength? Biggest wavelength. So this is the biggest wavelength.
Instead of big, she means longest.
Yes, I do. Who has the biggest energy, the most amount of energy? More energetic. Who's more energetic? 2. Okay, so think about it this way too. Think about it as when you go to the ocean and you have those long waves that take forever. Are they able to push you over? It's kind of hard, but when you start getting more frequent, you have more energy in there, and they start pushing you over. Okay, you start like eating salt water, drinking salt water, and you're just like.
Okay,
Any questions on this?
No, hold on, just don't go for it.
go for it.
You didn't even want to touch angle, so.
Only if you come up here and do a wavelength for me again.
Go ahead, do your thing.
Okay. For some candy.
I'll do it for some candy.
The answer is always candy.
You went for some candy.
That's what I need to do. I need to get my candy bucket.
You need to
You have a candy bucket?
I used to have one, but then the ants got into it. For like, you would trade in like three stamps for a for a piece of candy, or you could trade in like your 10 cards for 3 pieces of candy.
Excuse me. I have an idea.
Hey, I get like Laffy Taffies and like.
No, I
I'm a teacher. I cannot afford that.
have an idea. You should get a bucket of candy. That way, if we ask a good question and answer it right, you just throw a piece of candy at us. That way, it's fun for you, and we enjoy our meal.
I usually get Dum Dums and Smarties.
That's the cheap candy. Come on.
Dum Dums, Smarties,
And it's in my items.
and Airheads. Dum Dums, Smarties, and Airheads.
Whenever I
It is a
get
pun.
M&Ms and Snickers and Reese's and Kit Kat and Skittles.
You supply the candy, Kalia. Then we'll talk about that.
That's a bit.
Get on with it. I don't want to do this.
I can't. I can.
All right, amplitude. Amplitude is just the height of the wave. You don't have to know amplitude. I just want you to know that the height of the wave is not affected by the wavelength or the frequency.
Is the test gonna ever ask us like how long, like not how long, but how high the thingy is?
No.
Like it's not gonna. There's no measurement.
No. It'll be like, what's more frequent or what's the longest wavelength? Yes.
So the top part where it goes up is the crust or whatever, crust, whatever you want to call it.
Crust.
And then from the line up to that point, it's amplitude.
Amplitude to the height.
Like goes like
All right.
shut up, Brendel. That was good. That was good.
All right. C equals lambda times nu. C is the speed of light. And C is what value? 3.0 times 10 to the 8th meters per second, or 3.0 times 10 to the 17th nanometers per second. C will never change because C is constant. So anytime you see this, C is always going to be this times this. So if I tell you the wavelength is 50 meters, tell me the frequency. How are you going to do that? Do you have enough information to tell me that?
You plug in. Oh, you divide. Lexi's talking. Lexi's talking.
See, so Kalia didn't like my joke. So what's new? What's new?
Oh my God.
New is C over lambda. That's such a funny fact. C always, huh? Linda. C always gets divided by what we know.
Really? First off, I dropped my mouth because I understood. So shut up. What did you say?
Lambda is wavelength, and that is measured in meters or nanometers. And nu is the unit for new is hertz, HZ, or 1/2. Remind me never to record in this class again, huh? That is the unit for frequency.
People are gonna hear these and be like, what?
People are going to hear this and be like, ooh, that 7th period class. Ugh.
This is like on public on YouTube.
Yeah.
Like anybody can watch it.
Yeah.
These people, I mean, people don't care about this.
No, they're going to go, PAP Chemistry? Why would I want to watch that?
Do you have like cameras set up in here so we can like see what's going on?
No.
You should do that.
Why would you tell me? Shut up.
Well, I've seen it, so it's not. Oh, that.
Yeah, he just came in and replaced that.
Yeah, there you go.
All right.
Camera.
Listen up. Waves. Remember we said light travels as waves. But because of we see these different characteristics, it doesn't only travel as waves. It travels as other ways, as another way too. Okay? So one of the questions is, here we're heating up this metal. And this metal gets heated, and this one's like a bright, bright red, and this one's an orange. And so it wants to know why is it the guy, Max Planck, was like, why are these heating up and getting different colors? And so what he saw was that these two things, matter is gained or lost in small amounts, and we call that quanta. So matter can gain or lose energy in small amounts, called quanta.
So would I say I'm losing quantum? Yes, no, think so.
I guess, yes. A quantum, which is singular of quanta, is the minimum amount of energy that can be gained or lost by an atom. So you have to gain or lose that quantum to be able to move, electron to move from one orbital to the next. And he put this into an equation so that we can solve for energy.
So quanta is always small amounts, but you won't lose everything. But quantum Ham, whatever, you lose everything.
What? You lose energy in little packets.
For which one?
Either way. Quanta, this is plural of quantum.
Okay, so quantum.
So quantum, this is, instead of quantums, this is a quanta. This is a bunch of energy.
Oh. I could have just said that.
I did. I said it's plural. That's what a bunch means. Everybody good? All right. So this is how we're looking at it. We're not going up a ramp and we're getting this gradual increase. What we're doing is we're jumping from one stair to another. Jump, 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 jump. Okay? So we're jumping in little spurts, not in this nice little gradual increase. You see it in water when you heat water up? No. It looks like we're heating water up at a constant temperature, but it's gaining energy in little bursts, okay? And this is the equation. E, which is energy, is equal to H nu. H is Planck's constant, or Planck's constant, which means it's never going to change,
And V is.
which is 6.63 times 10 to the negative 34th joule times second. And it's on the reference chart. Nu, what does nu stand for? Frequency. And that is 1/2, which means what is E going to be measured in? If this is joules times second, and this is 1/2, joules. Yes, thank you. Okay? So if I gave you the frequency, if I tell you frequency of something, you should be able to tell me its energy. If I gave you the wavelength of something, you should be able to tell me frequency and energy by these two equations. Now, what did I say? I said, what's new? And you told me new is what? New is C over lambda. I can take new, all right? Or I can take C over lambda, and I can substitute that in for new.
Wait, you can substitute the C in or just the
I can take C over lambda and substitute that in here for new. So now E is equal to HC over lambda. That's those two equations put together.
Wait, so you wouldn't use the V for frequency?
I've just changed frequency out for this.
Wait, so is that 6.63 times 3?
Oh,
10
I see what you did.
4 times C
What?
over
Frequency?
Whatever wavelength. Okay? So these three equations, this one, and C equals nu times lambda or lambda times nu, whichever one, are three equations that you'll be given on your test or your quiz.
So you're going to give it to us, so I don't have to remember.
No. Yes. No. What?
Stop making me confused.
That's not easy. That's not hard to do.
Everyone stay loose.
Okay. So, your homework tonight,
You said we have homework first off.
should you choose to accept it,
Okay.
just fill it out and sign it for me. You have 10 minutes. You have your homework right here. This homework, I'm going to be stamping this actual homework. The only one that you're going to have to show work on is really the first 1 through 8, your math problems, your homework for tonight or tomorrow. The answers aren't there, so good luck with that. But you're going to do the work, and then tomorrow I'll come by, or Thursday I'll come by and I'll stamp your page. And then the next night I will assign this and so forth and so on. And then here after that you'll see is your test review. The back, so your test review is already there. This whole thing will be due on the day of the test. So you'll turn in your homework and your test review on the day of the test. Yes, Tori. It's up to you. If you can put it on here on the little, that's fine. Lambda is wavelength, yes. Any other questions?
And new is frequency.
You need to think about it.
Nu is frequency.